Okay. So the first thing that I want to talk about today, along with finishing up 4.7, is the ambiguous case of law, wow, writing today is a struggle, of sines and triangle area. So those are the two things we need to cover today. The ambiguous case of the law of sines is going to be the one that takes the longest to cover, just because in order to cover it well, we have to do 3 examples. So we're going to do that first, and then triangle area is actually super duper easy once you know how to use law of sines and law of cosines already. So that'll be the easier thing that we do today. But first, the ambiguous case of the law of sines. So this is the ambiguous case law of sines. This is the SSA configuration. So if you remember all the way back to geometry when you were doing triangle congruence postulates, you might remember asking your teacher if you had some smart aleck in your class, if there was an ASS postulate. And then the teacher would say, roll their eyes and say, no, there's not an ASS postulate, nor is there an SSA postulate, because that's not enough information to show that triangles are congruent to one another. So because of that, when we have the situation with the ambiguous case of the law of sines, for example, if I were to know that this was 60 degrees, this side length was 10, and this side length is 6, we could be talking about this triangle, but we could also be talking about a triangle like this instead, where we've got the side length 6 coming in this direction instead of out like this. So we don't know, are we talking about this triangle here, or are we talking about the big overall triangle there? And I guess the ambiguous case of the law of sines covers the situations where that does happen, where we end up with a case where we could end up with 2 triangles. And it also covers cases where you end up with no triangle or 1 triangle. So there's kind of 3 possibilities here. And that is why it is ambiguous. So there could be 2 triangles given by that set of information that you have. There could be 1 triangle represented by that set of information. Or there could be no possible triangles given by that set of information. So there are 3 different distinct possibilities. And in order to find out which possibility you're working with, you kind of have to start solving it using law of sines. So that's what we're going to do here. We're going to have an example of each of these possible cases. So first example. And the fun part is you'll get to find out as we go which case we're dealing with. So for the first example, we have triangle A, B, C. We have angle A is 117 degrees. Side A is 14. Side B is 15. And we are looking for the missing information here. Okay. So the first thing that we might notice is that, yes, we can indeed use the law of sines because we have an angle and a side that are across from each other. We have a pair, so we can set up our step 1 where we have the sine of angle A, which is 117, over 14 equals, and then we can do sine of B over 15. And we can find angle B in this fashion. So this is going to look a lot like the law of sines that we saw yesterday, when we were working with law of cosines. So once you did the first step with law of cosines, we ended up with a law of sines that looked a lot like this. So you can cross multiply if you like, or you can just multiply by 15 on both sides. Actually, that's probably the better method here. And then you get 15 sine of 117 over 14 equals sine of b. And then you take the inverse sine on both sides, just like we did right before this on the warm-up, or on the exit ticket from yesterday. And so then we type this into the calculator to find angle B. So we go sine inverse of 15 sine 117 divided by 14, enter. And we get angle B is 72.679 approximately degrees. Okay. So this is where we kind of get to step 2 here. Step 2 is figuring out that there are 2 possible angle B's. This is one possibility. And then the other possibility is that angle B is 180 minus the angle B that we found. So it could be the supplement of the angle that we found, which would give us 107.321 degrees. Okay, so now, amongst these 2 possibilities, we need to figure out if either of these work, if they both work, what the deal is. And so in order to figure out if they both work, step 3, you have to add measure of angle A to both, or the measure of whatever angle you have here. So if you have angle A, that's the one that you add to both of these. So for your first possibility, we had 72.679. And to that, I would add angle A, which was 117. And we get 189.679. Does anyone see a problem with that? I'll give you a hint. What are the angles of a triangle supposed to add up to if you add all 3 of them together? Yeah, it's over 180. That's a problem because triangles only have 180 degrees if you add all 3 angles together. So if I add just 2 of them together and I get more than 180, that's not going to make a triangle. So this is greater than or equal to 180, and that's a problem. So this version of angle B will not work. Well, we'll do it with the second one as well. We're going to take, we had 107.321 plus 117. And we know that's got to be over 180 because this was over 180 and this one was smaller. So this one also doesn't work. Okay. So that means that the triangle that we were given, or the information that we were given to make a triangle, doesn't actually make a triangle. So this one has no solution. Okay. So that first one, in the ambiguous case of the law of sines, this one has no solution. Okay. So kind of our 3 steps, if we want to go back and review those real quick. We did the law of sines to find one angle. We took 180 minus that angle to find the other possibility. We added the measure of the angle we already know to both. If it's greater than or equal to 180, then it doesn't work. If it's less than 180, then that solution will work. And then you can proceed from there to find the rest of the information about the triangle. Any questions off of this first example? Okay. So let's do another one. This time it'll either have one solution or two solutions, since we've already done the no solution case. This time, we're going to be told that side length A is 35, side length B is 24, and angle A is 92 degrees. So we would want to draw the picture then. And in this case, as always, just kind of draw a generic triangle. I'm going to call this one angle A, angle B, and angle C. And we know that side A is 35, side across from B is 24, angle A is 92. So it looks like we've been given the ambiguous case of the law of sines because we have side-side angle. So just as we did before on the first example, we're going to start off by using the law of sines. So we're going to go sine of 92 over 35 equals sine of angle B over 24. So we'd multiply by 24 on both sides, and we get 24 sine of 92 over 35 equals sine of angle B. Then we take the inverse sine on both sides, and we type this thing into the calculator. So we go inverse sine of 24 sine 92 over 35. And we should get that B is 43.259 approximately. And I'm going to call this B1, just so that I can kind of keep track of things a little bit better here. Then B2 would be 180 minus 43.259, which gives me 136.741. And now I want to check and see if both of these things work. All right, so my other angle that I already know is 92. So I'm going to add 92 to both of these. If I add 92 to B1, we get 135.259, which is less than 180. So we know that B1 works. B2, on the other hand, comes out to 228.741, which is greater than or equal to 180. So this one doesn't work. So this is the case where we have one solution. So I know that B1, 43.259 works out. Then I can find angle C and continue on and find both angles and then also the missing side. So I'd go 180 minus 92 minus 43.259, and we get 44.741, which is the measure of angle C. Then lastly, I need to find the length of side C, which we can also use law of sines to do. We can take the sine of 92 over 35, and then that's equal to the sine of angle C, which is angle C was 44.741, divided by the side length C. So here, I guess you would cross multiply, we'd get C sine of 92 equals 35 sine of 44.741. Then we would divide by sine of 92 on both sides. And then we would type this into a calculator to get C. The side length is 24.652. So if I was kind of gathering my answer all together, I would say there is one solution, and it is the solution where B is 43.259 degrees, where C is 44.741 degrees, and where side length C is 24.652. Okay. So again, the same process as last time, except last time we stopped here because neither of these worked. Once you find one that does work, then you proceed and find your other missing angle and your other missing side. Any questions with that one? Any numbers we're not sure where they came from, or steps we want to go back to? Okay. So we're going to do one more example for the ambiguous case of the law of sines. And it's going to be the case where we've got two solutions. So for example number 3, we're going to be told that angle A is 43 degrees, side length A is 25, and side length B is 28. So just like last time, we would draw our triangle. We have A, B, C, 43 degrees, side length 25, and of 28. And we're going to start solving it just like we did the last one. So for this one, go ahead and see if you can find both values for B. When you think you've got both values for B using law of sines, type "got 'em" in the chat. You started off with that equation, you're on the right track. All right. So if you typed in sine inverse of 28 sine 43 over 25, that would give you 49.804 for your first B value. Your second B value then would be 180 minus that, which is 130.196. So now what we want to do is figure out if either of those values work. And spoiler alert, they do. They both do. So you take B1 plus 43 because 43 was angle A, and you take B2 plus 43 since that was angle A, and you get, for this one, you get 173.196. 49.804 plus 43 gives you 92.804 degrees. So yes, both work. Okay, so since both work, we are now looking at two possible triangles here. So I'm going to do the work for one triangle over here and for the other triangle over here. So for the B1 triangle, first we know that angle B, if I'm going to collect my answer down here, we know angle B is 49.804 degrees. I'm going to have like my first solution and my second solution. For the second solution, angle B was 130.196 degrees. Okay, so for the B1 triangle, we'd go 180 minus 43 minus 49.804 because that's going to give us angle C. So 180 minus 43 minus 49.804 gets me 87.196. So that would be angle C. Then we want to do our law of sines. So we'd go sine of 43 over 25 equals sine of 87.196 over side length C. And so then by cross multiplying and dividing, we get that C is going to be 25 sine of 87.196 divided by sine of 43. And so we type that into the calculator, 25 sine of 87.196 divided by sine 43. And that gives us 36.613. Okay. So that's your first solution. Your second solution, go ahead, take a minute, and find the values of angle C and side C. When you think you've got it, type ready in the chat. If you started off subtracting from 180, you're on the right track. And then setting up an equation like that one. Okay, so if you're looking to check your work, for angle C, you should get 6.804 just by subtracting from 180. And then for side C, you should get 4.343 by using the law of sines and solving for C. Okay, so now we've seen three different possibilities for the ambiguous case of the law of sines. We saw no solutions, one solution, and two solutions. Any questions from any of those? Anything that we want to go back to? Anything, any numbers we're not sure about? Okay, so you're in luck. That was the harder of the two things that we had to do today. So if that wasn't so bad, then you're in good shape. If it was, sorry, we've got some time to work on it though, in practice before we have to get tested on it or anything like that. The second thing we're going to do today is the area of a triangle using law of sines and law of cosines kind of logic. So, area of a triangle. Okay, so first we have to think back to our elementary school, middle school geometry days. What's the formula for the area of a triangle? Who remembers? It has to do with length times width. Or a variation of that. But typically for a triangle, we call them base and height instead. And then we divide them by 2. Because length times width is a rectangle. Or base times height would be a parallelogram. And so if you want to think of a triangle as kind of like half a parallelogram, for a parallelogram, it's like that's the base and that's the height. And so you go base times height on a parallelogram. But for a triangle, it's like half of a parallelogram. So you divide it by 2. Anyway, that's our formula for area of a triangle. So we need two things in order to find the area. We need the base and we need the height. So this is still something that, depending on who you had for geometry and when you took geometry, you might have already done. As far as solving for the height using sine, cosine, tangent kind of stuff. So there's kind of two scenarios that you guys might see in terms of finding area of a triangle using sine, cosine, tangent. The first case, let's see, you might get something like this, where we have we'll go with, I'm going to grab one of the problems actually specifically from the assignment. So we'll have triangle ABC, and angle C is 35 degrees. And we'll say that this side length is 6, and or actually, sorry, we'll do this side length is 26 and this side length is 42. Okay, so if we're thinking about this triangle, this is going to be the easier of the two cases, because it doesn't really involve doing any law of sines or law of cosines or anything like that. It does involve using sine, but you don't actually have to find the third side or anything like that or any other angles, because what you can do with a triangle is you can drop a height from one corner to the opposite side. And then if this is the height, this would be considered the base. Because the base and the height have to be perpendicular. So then, if area is base times height divided by 2, I can just use this right triangle that I have formed here in order to find the height. So if this is the angle that we're using, and this is the side that we're using, and this is the side that we're using, and I want to find h, I can just use sine. I can go sine of 35 is equal to h over 42, since that's the opposite, and this is the hypotenuse of this little right triangle that we have going here. Then we just multiply by 42 on both sides, and we notice that the height is 42 sine of 35. You can make this a decimal if you would like to, or you can wait to round until the end. I tend to like to wait on the rounding, because now we have the height, we have the base, we can plug it into our formula. The base was 26, the height is 42 sine of 35, and then it's all divided by 2. And now we type it into the calculator, and we go 26 times 42 sine of 35, all divided by 2. And we get 313.173 square units. Okay, so that is one case that you'll end up with, and that's the easiest case. The other case is where you might have to actually use like the law of cosines or something like that in order to find an angle and find your height and whatnot. So that's what we'll do next. For this one, we are going to be told that side length A is 8 inches, side length B is 4 inches, and side length C is 5 inches. And we want to find area. So we would draw our triangle, A, B, C. We know side length A is 8, side length B is 4, and side length C is 5. And you can drop a height to whichever side you want. I'm just going to drop a height from A down. It's typically easiest to drop a height to your longest side. But anyway, if I would like to find this height, I need to figure out what this angle is, just like we had up here, where the angle was given to us. So in order to figure out what that angle is, we're going to have to use the law of cosines. Okay. So for law of cosines, if I would like to find angle B, then I need to use b squared equals a squared plus c squared minus 2ac cosine of b. Because the first and the last are always the ones that are the same. So if you're looking for a particular angle, that's the one you want to use. So we know that b is 4, so 4 squared equals a is 8, c is 5, minus 2 times 8 times 5 cosine of b. Then, simplifying here, we know this is 16, and then we've got 8 squared is 64, plus 25 gives us 89. 2 times 8 times 5 gives us 80 cosine b. Then subtracting 89 from both sides. 16 minus 89 gives us negative 73 equals negative 80 cosine b. Then dividing by negative 80. We just get 73 over 80 equals cosine of b. Then we inverse cosine. And we get angle B is 24.147 degrees. 24.147. Okay. So now I need to find the height, and this turns into a problem just like the one we had up here. This is my base. And then I'm going to use my angle and the fact that h is opposite of that and 5 is the hypotenuse to find the height. So sine of 24.147 equals h over 5 times 5 on both sides. 5 sine of 24.146 gives us 2.045. Or if you'd rather not round it until the end, we can wait. Either way, you should end up with a pretty good answer if you're going out to at least 3 decimal places in between. But if you can help it by not rounding, that's usually a good call. Anyway, the final part, finding the area, base times height divided by 2. So 8 times 5 sine of 24.147. If you want to get a really, really accurate answer, you could use cosine inverse of 73 over 80 inside here for the angle instead. But we don't need to go quite that far. Anyways, 8 times 5 sine of 24.147 divided by 2 gives us an area of 8.182 square inches. Okay. So looking at either of those two problems with area, any questions, comments, concerns, anything we want to go back to? Anything we're not 100% sure about? Okay. So on a scale of 1 to 5, 1 being I'm completely lost, 5 being this is super easy. Why are you still talking? Where are we at? Okay. So looks like we're mostly in the 3 to 5 range. Awesome. I'm going to go ahead and post the assignment. We'll talk about it, and then you guys can go enjoy your Friday. So today's assignment is going to be a worksheet instead of an IXL, because then we can do a little bit, or we can do a wider variety of problems without doing a crazy amount of work. So the first couple of problems are all ambiguous case of the law of signs type of problems. So there's 4 of those. We have one application problem here with a ski hill or mountain, I guess. And then we've got more ambiguous case. We have a couple of the non-ambiguous case. And then actually those might be side angle sides. Those might be law of cosines. And then we've got another one with the triangle actually given to you. And then we've got a couple more, one more application problem. And then down here, we've got the area problems. So we've got 1, 2, 3, 4 area problems. So yeah, that's what we've got for this worksheet today. It's a bit of a review of everything we've done over the last couple of days. So just as always with worksheets, complete the worksheet, upload pictures or a PDF of your work when you're done, and we will go over any problems that you guys want to, or any that you get stuck on or anything like that on not Monday, Tuesday, because we don't have school Monday. Okay, and then I'll also post an exit ticket. Any questions before we go? All right, then feel free to stick around if you do have questions that you just didn't want to ask with everybody here. Otherwise, have a wonderful day, and I'll see you guys Tuesday.